Hello, welcome everyone. Good afternoon. The Exploring the Feasibility of Offshore Wind Energy for the California North Coast webinar, hosted by the Schatz Energy Research Center at Humboldt State University in partnership with the California Ocean Protection Council, will begin momentarily. We are so glad you are here with us a few minutes early. We welcome you to send us a message in the chat if you are having any technical difficulties, or email us at windstudies@schatzcenter.org. And using those two methods, we'll be more than happy to help you out. We've also muted the lines to minimize background noise and encourage you to complete the poll that will be shown on your screen so we can get a chance to know who has joined us for today's webinar. Thank you and stay tuned. Hello, everyone. Thank you to those of you that are joining us for today's webinar. Just wanted to say that the Exploring the Feasibility of Offshore Wind Energy for the California North Coast webinar, hosted by the Schatz Energy Research Center in partnership with the California Ocean Protection Council, will begin momentarily. We welcome you to fill out the poll on your screen so we can get to know you. And please, if you're having any technical difficulties, email us at windstudies@schatzcenter.org or send a message using the chat function in Zoom. Okay, welcome everyone. It is 2 o'clock, so I will begin. Hello, my name is Sarah Shen with Strategic Earth Consulting, and on behalf of the Schatz Energy Research Center at Humboldt State University and the California Ocean Protection Council, Thank you so much for joining us for the third in a series of 5 webinars on the topic of offshore wind energy for the California North Coast. We've been welcoming folks as you've been joining, and we acknowledge that a few more folks may be joining us for the conversation. We just wanted to say out loud that we have muted everyone in an effort to minimize background noise, and we will keep folks on mute until we get to the community Q&A and discussion, and then we'll invite participation. For those of you who have joined us before, welcome back. And for those tuning in for the first time, thank you for taking the time and holding the space to join this really important community discussion. We acknowledge that there are a lot of significant stressors going on right now with ongoing fires, the pandemic, social justice conversations, and we just really want to extend our deepest appreciation that you've joined us today and taken the time to be here. It means a great deal, and our well wishes are with you and your loved ones, and ensuring your safety comes first. So whether or not you've tuned in for previous conversations or whether today is your first time joining us, we wanted to flag that the agendas, the webinar recordings, and the PowerPoint slides from the first 2 webinars are posted on the SHOTS Center website. And you will also find today's agenda and relevant reports posted there as well. And in just a moment, we'll be dropping in a link to the SHOTS Center website where you can find more information about previous and upcoming webinars, as well as the reports that I just mentioned. This webinar is being recorded and closed captioning is available. If you click on the CC on the bottom of your screen, that will enable the closed captioning. And if that doesn't work, you can always visit the URL that we're going to drop into the chat, and that will take you to closed captioning as well. It's important to provide some context that this webinar series was originally intended to be an in-person workshop last spring, and we all wish that we could be together in a room to have this conversation. Obviously, that workshop was postponed and modified due to the COVID-19 pandemic. And so the SHOTS Center, with the support of the California Ocean Protection Council, has been working really hard these past few weeks and months to redesign that workshop into a series of webinars to engage with the North Coast community and others interested in renewable energy. The purpose of these webinars is to share the findings from the research completed by the SHOTS Center and their partners in the last 18 months to explore the feasibility of offshore wind for the North Coast of California. Each webinar focuses on a theme of that research and provides a very high-level overview of the key findings. So if you find yourself interested in learning more about one or more of the topics that we explore together, we invite you to visit the SHOTS Center website and take a look at the 20-something reports that are available online. There are 3 more reports that will conclude this series of reports, and those are expected to be available before the end of the year. The remaining 20 reports are up and ready for your reading pleasure. So again, we're so grateful that you joined us for today's discussion, and we acknowledge all that's going on again. So thank you for taking the time to be here today. And now I'd like to turn it over to Dr. Arnie Jacobson, Director of the SHOTS Center, to hear from him with his opening remarks. Arnie, please go ahead.
Thank you, Sarah, and good afternoon. As Sarah noted, my name is Arnie Jacobson, and I'm Director of the SHOTS Energy Research Center at Humboldt State University. Really happy to welcome you to the third in our series of 5 webinars on the feasibility of offshore wind on California's North Coast. As Sarah noted, for the past 18 months, our team and partners have been carrying out a multidisciplinary study to examine various aspects of offshore wind feasibility. This work has been supported with funding from the Ocean Protection Council of the California Natural Resources Agency, the Governor's Office of Planning and Research, and the Federal Bureau of Ocean Energy Management. Pacific Gas and Electric also contributed by providing self-funded analysis related to transmission alternatives. We're grateful for all of this support. Over the past few weeks, we've been asked a few times about the goals of this analysis and our interest to carry it out. I want to take a few minutes to share a bit more about our objectives. The SHOTS Center is, of course, deeply committed to research aimed at increasing the use of clean and renewable energy and helping to address global climate change. These goals are core elements of our mission as a center. The offshore wind resource here on the North Coast is enormous, and it provides great potential to generate substantial amounts of renewable energy. A full build out of the Humboldt Call area could generate as much as 4% of California's electricity with a renewable resource. 4% is a very big number. Developing an offshore wind farm could also generate jobs and contribute to economic development on the North Coast. Given the urgent need to take measures to address climate change and the importance of economic development in our region, it should not be surprising that we think offshore wind is an opportunity that is worth analyzing. At the same time, we know that offshore wind development, like any large endeavor, involves a lot of complexity and potential for negative local impacts. If offshore wind is to be pursued, we believe strongly that issues such as environmental impact, cultural resources, geologic hazards, and conflicts with existing uses such as commercial and recreational fishing must be considered, understood, and addressed. We also believe that a collaborative approach that actively involves North Coast communities would result in a better project. I also want to clarify another key point. Currently, there is not an offshore wind project in our region. BOEM has established the Humboldt Call area, an approximately 200 square mile area, which is situated 20 to 30 miles offshore from Humboldt Bay, but no lease auction has taken place so far. The earliest that this is likely to happen is sometime next year. Companies that develop offshore wind have expressed interest in pursuing a project, and some have conducted preliminary analysis and outreach. The analysis that we are presenting here is not connected to those commercial efforts and is not supported in any way by private offshore wind interests. Our analysis instead is funded by state and federal agencies. So you might ask, why are we doing an analysis of hypothetical scenarios and reporting out on them at this point? We're doing this because we believe that consideration of offshore wind or any complex project that can bring benefits and impacts to our community should be approached with knowledge and shared understandings. Developing this knowledge takes time. Our goal, therefore, has been to carry out careful analysis on a range of topics relevant to offshore wind and to share this information publicly well before the lease auction occurs and before there is a proposed project. With information in hand about the opportunity, the challenges, and the impacts, we are all hopefully in a better position to consider the possibility and develop or refine our perspectives. We realize that a lot of the information is complex, and our team's reports, which are available on our website, may not be easy for everyone to digest. For this reason, we wanted to report out in a public setting to share what we and our partners have learned, to discuss the implications of our findings, and to answer questions. We know that we cannot cover everything from the reports in these sessions, but we are doing our best to introduce key issues. We designed each of the sessions to cover specific topics through presentations from our team, and also to include a panel involving people with specific expertise or perspective that is relevant to the webinar. For example, this week we are covering potential changes to port and coastal infrastructure in relationship to offshore wind development. As panelists, we invited representatives from the Harbor District, given their role in port development and operations, the Wiyot tribe, given their long-standing connection to and stewardship of the bay and surrounding areas dating back thousands of years, Principal Power, an offshore floating platform supplier that can speak to the suitability of the port for deployment of offshore wind technology, H.T. Harvey to discuss environmental impact concerns, and the Coast Guard, given their role in ensuring safe and orderly operation of the port and coastal waters. We know that there are many other relevant perspectives, but 5 panelists was the number we thought we can reasonably include today, given time constraints and an interest to allow ample time for audience questions and answers. We hope that the session is informative and useful. It's now my pleasure to introduce Jennifer Lucchesi, Executive Officer of California State Lands Commission. In over 2 decades at State Lands, Jennifer has a long history of leadership in relationship to the development of ports and coastal infrastructure in California. It is a pleasure to have her with us to make remarks to open today's session. So I'll pass it over to you, Jennifer.
Thank you. Thank you for inviting me to help set the stage for this important webinar today. Are you able to see me? I'm sorry. Yep, okay. Thank you. It is my pleasure to be here as the Executive Officer for the California State Lands Commission. The Commission is excited to be one of the leaders of California's transition to a clean energy future and to work in partnership with all of you here along the North Coast to figure out the best path forward to reduce our reliance on fossil fuels, take action to combat climate change, and ensure that our environment and economy can thrive together through a thoughtful and comprehensive just transition. Meeting California's climate goals requires focused action to quickly transform the state's energy system away from fuels that generate greenhouse gases. You are all aware of the various legislative and executive actions our state leaders have championed, from Senate Bill 32 to SB 100 to numerous executive orders, including Governor Newsom's most recent order he announced last week. We have our North Star. We know where we need to go, and now we're in the business of how. How do we achieve our bold objectives and goals? How do we actually realize our clean energy future that benefits all Californians? And that is why this webinar series is so important, because we are focusing on the sectors that are critically important, not only for supporting offshore wind opportunities, but also for considering the entire life cycle of offshore renewable energy in a comprehensive way where we can ensure a sustainable and ever-growing economy that supports living wages and ensures a just transition for all communities. As a land-owning agency that oversees the management of approximately 4 million acres of public tidelands and submerged lands, we, like our ports and harbor districts, are working hard to diversify our leasing and revenue generating portfolio and position ourselves to be partners in facilitating our clean energy future. As stewards of these lands and resources, we facilitate their use consistent with the principles of the public trust doctrine. This doctrine is the foundational legal and policy framework that guides the Commission and its local trustees in the management and protection of our tidelands, submerged lands, and navigable waterways. The public trust doctrine paves the way for responsibly transitioning from our fossil fuel dependency and embrace our renewable future. The underlying principle of the doctrine is that as a common law doctrine, it evolves as our society's needs and values evolve and change over time. This doctrine, this policy, this legal framework is not static, but evolves as our communities evolve. For example, throughout the first half of the 1900s, California determined that oil and gas development in state waters was an appropriate use of these lands and was in fact a priority. As Californians evolved in their priorities and values, the legislature reflected these values in restricting new offshore oil and gas development and establishing renewable energy goals and incentives. Many of these public trust lands and resources, including much of Humboldt Bay, have been granted by the state legislature to local jurisdictions for day-to-day management and use. These local jurisdictions, like the Humboldt Bay Harbor District, issues leases for the use and occupation of state lands and resources under the same public trust framework as the Commission. The state's tidelands and submerged lands are the literal foundation of California's blue economy, a $44 billion economic engine that includes the dynamic commercial fishing industry, commerce and trade, coastal energy production, one of the strongest recreation and tourism economies in the world, and of course, unique and incredibly biodiverse ecosystems protected through the strongest marine protected area network in the world. While the state's tidelands and submerged lands support a broad range of uses that can be consistent with the public trust doctrine framework, those uses are not always compatible with one another, and they are sometimes in competition for space and resources. This is why we must always strive to engage and truly listen to our stakeholders, communities, and our sovereign tribal nations to understand their important perspectives, priorities, and values surrounding a given land use decision and public trust needs. These voices are integral to deepening the state's understanding for determining our best path forward. In conclusion, we all have a role in advancing a clean energy future. It is critical to promote and practice transparency and understand the current state of the ocean and coastal space, put all the facts on the table so that everyone is aware of the potential benefits and trade-offs, so that our decision reflects society's values and priorities for our current and future generations. As we think about the improvements needed to our current port and harbor infrastructure for facilitating clean offshore renewable energy, let us think outside the box for strategies that yield multiple benefits and minimize negative impacts, focusing on our low-income and historically disenfranchised communities. Responsible management of the public trust, which often is achieved through meaningful partnership and relationship building, is designed to support a robust blue economy and a vibrant environment. Thank you very much.
Fantastic. Thank you so much, Arnie and Jennifer, for a great start to the webinar. I'm going to screen share. Okay, so again, my name is Sarah Shen, and I have with me my colleague, Carolyn Kraft, and Strategic Earth has been contracted by the Schott Center to help design and facilitate this webinar series. We'll also be helping to lead the development of a webinar summary report that I will speak to in a little bit. I just wanted to mention that as neutral facilitators, we are committed to upholding an inclusive, transparent, and productive dialogue today and over the coming weeks. So if you have any questions or concerns about how we're supporting this conversation and upholding our neutrality, please contact us directly at hello@strategicearth.com, and we will drop that link into the chat. So now, to get to know all of you a little bit better, you've heard some opening remarks and introductions from our behalf. I would love to take a look at the poll results and see who's joined us. Perfect, so those have just been shared. We have 40% of our participants identifying with the California North Coast as where they live or work, 31% outside of the North Coast, still within California, 23% outside of California, still within the US, and 6% of international folks. So thanks everyone for tuning in, and from all sorts of time zones as well. So this helps us to just understand who's on the call, and as I'll mention in a little bit, when we get to the Q&A, it really helps us to make sure that we're hearing from the diversity of voices that are on the phone today and on the webinar. So thank you for completing that poll. So if you are having any technical difficulties, I'll just say once more, you can't view the screen share or you don't see the Q&A chat box, please email us at winstudies@schottcenter.org, or you can send a message via the chat in Zoom. And those are the two ways that we can help to make sure that we resolve those technical difficulties. As I've mentioned, the webinar is being recorded, transcribed, and closed captioning is available. So we're doing our best to make information transparent and broadly accessible. We are recording the webinars and making them available on the Schott Center website in order to disseminate the information and also accommodate conflicting schedules. So we understand that it's hard for some folks to be here today, even if they're interested in the conversation. All participants are muted, and everyone will remain on mute throughout the duration of the webinar until we get to the Q&A so that we can help to eliminate any background noise. In an effort to take as many questions as possible and adhere to the timeframes that we've outlined in our agenda, we encourage you to submit your questions via the Q&A or by email. And so this approach to taking questions has worked really well for us for the first two webinars. And folks opted out of raising hands and speaking out loud, which enabled us to get through even more questions. And so it's been working really well. That being said, we may not be able to address every single question that comes in. And so I just want to acknowledge that the Schott Center is developing a public-facing FAQ document that will be available at the close of the webinar series. And the development of that report will consider all questions received, whether or not they were said out loud. So please, don't despair if we can't get to your question today. It is absolutely being considered for the FAQ document. So some further webinar considerations. Today's agenda, as well as the two reports that are most relevant to the discussion, have been posted on the Schott Center website. And so today's webinar is focusing on information shared in these two reports that are shown on your screen, and we'll also send those links via the chat. Coastal Infrastructure Co-Benefits linked to the offshore wind development, and export cable landfall. There is a third report on port infrastructure assessment that's still in the final stages of development and review. And so it's anticipated that it will be available for all of you to read and download before the end of the year. So just encourage you to check back the Schott Center website, early and often for the latest updates on reports and other information. You do have the opportunity to share your feedback today on your webinar experience so that we can learn what's working well and what needs further improvement. All feedback shared will be anonymous, and we are not collecting any personal information. We've really benefited from the feedback that we've received so far, and it's enabled us to make a few changes to each subsequent webinar to ensure that we're really hearing from the participants' experience and making those updates in the way that the webinars are designed. So thank you to those that have been sending in that feedback. I will introduce how to submit that feedback and fill out that survey at the start of the community Q&A and the discussion agenda item. So I've mentioned a summary. This summary will be developed for the entire webinar series. So one summary across the series, not a summary for each webinar. And this summary will highlight the key themes of each webinar, as well as the diversity of perspectives and questions that we've received. It'll be available, like everything else, at the Schott Center website, and we hope to have this published before the Thanksgiving holiday to kind of wrap up this portion of outreach. The poll and the survey results may be included in the summary at a very high level, but again, those results are anonymous. So in the interest of time and being mindful of the large number of participants that we have today, I'm not going to read out these webinar agreements, but I will just say kindly that we're going to move forward with the understanding that everyone is willing to abide by these agreements here. And these agreements are just laid out in a way that creates a safe and welcoming environment for folks to share their ideas, their thoughts, their questions, and their perspectives. So thank you in advance for reading through the webinar agreements and abiding to those during today's discussion. So hopefully many of you have seen the webinar goals before you joined today, perhaps in the agenda that's been posted. But just to make sure that everyone's starting from the same foundation, there are 3 goals of our conversation today. So the first is to continue to engage with the North Coast community and others that are interested in renewable energy about the feasibility of offshore wind off the California North Coast. Secondly, to share key findings from the offshore wind energy studies conducted by the Schott Center and their research collaborators related to port and coastal infrastructure requirements, constraints, and opportunities. And lastly, to create a space and facilitate a Q&A and a discussion around port and coastal infrastructure considerations that are related to the feasibility of offshore wind regionally. So a brief snapshot of the agenda is shown on your screen. Just wanted to highlight that the panel discussion will be taking place following a presentation about the research findings for port and coastal infrastructure. And then wanted to flag that we will make that Google Form survey available and live during the community Q&A and discussion, and would welcome your feedback at that time or any time really before you depart. So we may need to adjust the timing of the agenda in real time to reflect the needs of the conversation and the flow of information, and we will not be taking any scheduled breaks. So please take care of yourself. Okay. And so now we're really going to get into the meat of the conversation. And Arnie is gratefully and graciously going to provide a very brief recap of the first webinar highlights. So recognizing that some folks have been able to join us for the previous conversations while others are tuning in today for the first time, our goal with Arnie's presentation is to highlight the purpose and the scope of the offshore wind energy studies conducted by the Schott Center, and also touch on any perspectives or questions that have been shared by participants in previous webinars that are relevant to today's discussion and bring those back into the conversation. We're hopeful that this overview will help everyone enter into today's conversation with the same foundational knowledge. So Arnie, with no further ado, I'd love to turn it over to you. Fantastic. I will stop sharing my screen.
Thank you.
Take it away.
All right, thank you. So thank you again, Sarah, and a pleasure to be with all of you today. As Sarah noted, I'll just give a very brief introduction and recap. As we've been discussing, the technology or the type of wind system that we're talking about is a floating platform offshore wind system, and floating platform systems are needed because the waters offshore from our coast are quite deep, and that's true actually all along along most of the Pacific coastline. Floating platform systems are an emerging technology. They've been demonstrated through installed systems in Europe, but they're still very much less common than the fixed bottom or fixed foundation offshore wind systems that are much more commonly deployed. The systems that we're talking about are quite large. The scenarios that we analyzed assumed a 12 megawatt turbine with a hub height that's about 450 feet above the ocean surface. We've included a humpback whale that's just a little over 40 feet in length in the image for scale. And so you can see that these machines are quite enormous. In terms of our study scenarios, we looked at 3 different scales of offshore wind system. One, the smallest, was a 50 megawatt wind farm that might involve 4 12 megawatt turbines. We also looked at a 150 megawatt wind farm scenario that might be something on the order of 12 turbines. And then we looked at a full build out of the Humboldt Call area, which is the area shown here that's been designated by the Bureau of Ocean Energy Management. A full build out could hold a little over 150 turbines, which would correspond to about 1,800 megawatts of installed capacity. We also looked at a few different transmission line scenarios to connect to the main electrical grid, and these included an overland route to the east, an overland route to the south, and an undersea cable to the San Francisco Bay Area. The full scope of our research is shown here in terms of different topic areas that were covered. In the first session, first webinar of the series on September 14th, we covered a resource assessment, grid compatibility and transmission, a subsea cable, and economic analysis. In the second webinar last week, we covered environmental impact and geologic and seismic hazards. This week, we're covering port infrastructure and also the part of the subsea cable that relates to a cable, the cable landing or bringing the power on shore. And we'll continue on to cover other topics next week. In terms of key points from the first webinar, we noted that the offshore wind resource here on the North Coast is very large and that could make a substantial contribution to meeting California's climate and clean energy goals. We noted that transmission capacity is a major barrier for developing offshore wind on the North Coast. In terms of economic viability, we noted that larger wind farms achieve lower costs due to economies of scale. And so while smaller initial projects could be used to demonstrate the technology, developers will likely want to see a pathway to larger projects to achieve economic viability. And that offshore wind has good potential to create a significant number of jobs in our region as well as elsewhere in California. Last week in the second webinar, as I noted, we covered environmental impacts and geologic and seismic hazards. In terms of environmental impacts, a quick summary, we noted that both onshore and offshore impacts have to be considered. That during the construction phase, impacts are expected to be short-term and relatively localized, while of course operation and maintenance impacts would take place over a longer time period. We noted that there were significant uncertainties related to environmental impacts, especially for seabirds and marine mammals, and extensive monitoring and adaptive management would be needed. In terms of the overland transmission lines, these could involve long-term impacts, including to terrestrial and freshwater biota and habitats. And in all cases, the analysis indicated that there are likely opportunities for mitigation of environmental impacts. When it comes to geologic hazards, There are significant potential geologic hazards within the region, and these would need to be investigated and addressed for in the case that an offshore wind farm were to be developed. Today, we're considering port and coastal infrastructure development in relationship to the possibility of offshore wind. This development would take place in the context of the Humboldt Bay. And so while we're doing this, I want to remember and acknowledge that Humboldt Bay is in the ancestral territory of the Wiyot people. And I further want to note that when we think about infrastructure and operations related to North Coast offshore wind development more broadly, depending on how it's structured, it would likely cut across the ancestral territories of multiple Native American tribes. There are over 109 Native American tribes that are federally recognized in California, and a number of additional tribes that are not federally recognized. And so depending on the routes of the transmission lines and the location or the extent of the offshore operations, certainly those would be in areas that were that have been used over time by a number of different Native American tribes. Our team is engaged with tribes in the region to share and receive information, including 2 meetings that took place in February of 2020 involving representatives from over 10 tribal governments. And we would be happy to continue engaging with tribes in our region if there's interest to do so. And conversations we have indicate that that interest is there. With that, I will close, acknowledging again those our funders who provided support, as well as all of the members of our team who were engaged in this analysis, from the Schatz-Energy Research Center, more widely at Humboldt State University, and also with our major partners. And with that, I will pass things back to Sarah.
Thanks, Arnie. That was a very helpful presentation. Okay, so now we're going to transition into our next agenda item, explore research findings related to the port and coastal infrastructure. And Shane Phillips and Aaron Porter are project researchers with McDonald's. Together, they're going to tag team to present analyses of the port and coastal infrastructure that would be required to support offshore wind from the Humboldt Bay Harbor. And they'll also be discussing the potential use and the environmental impacts for the bay. Following their presentation, we'll move directly into a panel discussion with 5 community members of diverse expertise and backgrounds, and we'll be hearing from those panelists about their impressions and implications of the research findings that we've just learned from Arnie, Shane, and Aaron. I just wanted to take a few minutes to mention that we have been hearing from folks through the feedback survey that they wished presenters had more time to dive into deeper details of the research and the findings, while at the same time, we've heard from other folks that they wish that the panelists had more time to share their thoughts and impressions and continue that dialogue. So we really do appreciate the feedback, and we're continually trying to fine tune things to strike the perfect balance of having enough information learned from our presenters so that we can all be on the same page, acknowledging that those reports for the most part are available for you all to take a deeper dive, while also giving our panelists enough time to share their thoughts and insights and lead into a discussion with all of you, because really we want to hear from all of you what your questions and concerns and perspectives are. So just wanted to share that out loud as we move into the next agenda item. Okay, so as a reminder, lines are muted. We've been getting some questions in through the Q&A, so welcome you to continue submitting questions via the Q&A box and during email throughout the presentation, and we will turn to those at the appropriate time. So Shane and Aaron, I'm going to turn it over to you next, and just confirming that we have you speaking for about 30 to 35 minutes, so ending around 3:05, and I will flag you at the 5-minute mark if that's helpful.
Okay, thank you, Sarah. So Aaron and I are going to tag team the presentation here. I'll start with some of the preliminary introduction and background, and then I'll pass it over to Aaron more of the details. Just a few quick introductions for us before we dive into it. Again, Shane Phillips, Vice President and Deputy Coastal and Ports Practice Leader for Mott McDonald, 27 years experience working on port coastal facilities up and down the West Coast. And Aaron?
Yeah, Aaron Porter, Ports and Coastal Engineer. Shane and I have collaborated on investigation of floating offshore wind and port facilities here on the West Coast since about 2015. And yeah, excited to go through the findings of the study.
And so our role here is as the technical specialists from the ports and coastal perspective to take a little closer look at Humboldt Harbor supporting any potential future development of the North Coast offshore floating wind. And in fact, Aaron and I co-authored a study back in 2016 for the Bureau of Ocean and Energy Management looking at a broader scale study up and down the West Coast from California to Washington. And so this study gave us an opportunity to take a little bit closer look at Humboldt specifically. So on the next slide, a little bit of an introduction. So as Arnie mentioned, the purpose here is to provide more information and on port infrastructure requirements to a range of folks from the government and industry to stakeholders. And then the topic is would be the what. So we're exploring the existing capability and feasibility of infrastructure improvements that would be needed to support that offshore floating wind at a potential call area that Arnie showed on one of the prior slides. So a few things on terms. When we talk about ports and coastal infrastructure from a ports perspective, it's a combination of the navigation facilities, and what you see in the photo there is the entrance to the harbor there with the jetties. That's a co-shared piece of infrastructure between the Harbor District and the U.S. Army Corps of Engineers. But then other infrastructure is the wharf and landside structures. And then on the coastal side is more of the mid-ocean. It's the ocean swells and currents and things like that. So this was a full kind of review of all those different elements, but then with a specific focus on offshore floating wind. So the next slide. So this is an outline of what we're going to be going over. Again, I'll give a little more focus on the introduction and background, then I'll pass it over to Aaron. He'll go into a lot more detail on the findings on the port infrastructure. And then one other element of our work was looking at a cable landfall for bringing power through a transmission line to shore from the wind farm. So, so here is a graphic. Again, Arnie showed on the left. This is an example of one that was installed in Portugal. It's roughly about half the size of the one that we're going to be talking about today as our assumed size for the wind farm development. But this graphic you see here is going to be similar to you'll see in a variety of slides here as we proceed through our discussion. So the wind farm is there in the circle there. It's roughly about 20 miles offshore. In order to install these devices, there's a combination of things that would need to happen. There's components that would need to come in through vessels, deep draft vessels, barges, and other types of specialty vessels that will come in from the ocean and then transit through the navigation channel into the inner harbor at some type of marine terminal. That's the landside facilities, the berth and the dock. Then those components are stored, assembled into the final device, and then those are towed back out through that same navigation channel, through the entrance, and then back out and for the deployment out at the wind farm. Slide. So again, navigation is the kind of backbone of infrastructure element for a marine port, and that's why we've got this broken into two components: first the navigation, and then marine terminals. And so yeah, so if you can go to the next slide. So on the scope, Arnie mentioned some of this as well, but first and foremost, as engineers doing a planning level study, we want to start with what are some of the important criteria for our assessment and evaluation. And those were the build out size, supporting a small build out size of 150 to 300 megawatt, or a larger size at 1800 megawatt, approximately 150 units at the 12 megawatt size. So based on that, then our work was to evaluate relative to those two different classifications, and then using the best available information, knowledge of similar types of systems elsewhere in the world, and industry outreach with various folks, is to then evaluate, first, identify the capabilities and gaps within the existing port infrastructure. And again, keep in mind that's both the navigation channel and then the landside facilities. And then based upon that, develop recommendations for what kind of port infrastructure upgrades might need to be done to meet those different scales of build out. And then develop some opinions on planning level construction costs, as well as potential for schedules. And so what you see here is a graphic is an actual offshore wind farm port facility in Europe. And it's probably on the scale of approximately what the large build out might be. And so in the next graphic, this is a rendering that was put together that provides an idea of very generic or kind of overview of what this might look like in the upper harbor at Humboldt. And so we wanted to show first, before we got into the details, kind of what are we talking about based on a prototype in Europe. And then this is kind of a mid-scale size here at Humboldt to give some idea visually of, as we go through the details, what elements that we're talking about. Next slide. So again, sizes, this gives a good scale for some of the smaller, earlier development of wind farms, some of those on land. And then as you move to the right, you're getting into the much larger sizes. The size we're looking at is way over on the right-hand side, which is 12 megawatt. You can see a smaller scale size at 8 megawatt, its scale relative to the Washington Monument. So these are very, very large structures and components that need to be assembled into this and then towed out. Another kind of interesting fact here is Aaron he's a baseball fan, he put this together. This gives you another idea of scale. This is the base, and not the turbine up above, but the base, superimposed on a baseball field. This is Giant Stadium. So this thing would barely fit within the base, within a baseball field, and then be extremely tall. The bottom line is, with such large components, it's going to be marine transportation system dependent. And that's where the marine ports come in. These need to come in, components need to come in by offshore means through deep draft vessels and other specialty vessels that you see there on the left and the right, but then towed back out through that same marine infrastructure for deployment in the call area. And so just a quick recap, this is in the 2016 BOEM study that's available online as well. And some of the, like I mentioned before, this was looking at a variety of different port facilities up and down the West Coast, but very broad brush. And so the basis of this study that we're talking about today, some of that came from the 2016 study, and specifically for Humboldt was identified in that study as having a high potential for development to support offshore floating wind. In particular, some of those things identified was no air draft restrictions, again, because these are extremely tall, don't want to have any air draft restrictions. Having the available water depth that would be needed for a navigation channel. Wave climate, we've got a protected harbor that the assembly of these devices can occur and don't have to happen out in more open water or open ocean conditions that provide, that would be a lot of limitations. And then the close proximity to the potential call areas as well to minimize the amount of transit time. And so some of the other elements was that, just being able to evaluate it as a component of offsite fabrication being brought in through marine transportation of individual components and then final assembly, or there was possibly the option of also having on-site fabrication as well. Slide. So this is an oblique aerial of Humboldt Harbor. So it just gives you an idea. Some of the terms here just generically is the North Spit and the South Spit with the entrance jetties, big rock structures there right at the entrance. And this, these are the navigation elements, navigation channel. So you have the entrance channel. It's a deeper, wider channel as you enter from the ocean into the harbor. This is larger because of it's more exposed to the wave climate and motions due to waves, but also more sedimentation. And then as you come into the entrance harbor, then there's the Fields Landing channel that's located to the south. It's a smaller channel for smaller vessels and barges. And then the so-called deep draft. These are the bigger commercial vessels that I showed on the prior slide. Those would be transiting the North Bay Channel and have access up through to various facilities along the North Spit. And then from marine terminal perspectives, there's the RMT1 and RMT2. Those are existing and facilities that were developed based on the navigation channel to support forest products industries. And then again, the Fields Landing, a smaller facility to the south. So you'll be hearing about those. And so one
Shane,
last graph.
I just wanted to hop in for a second. I'm not sure if you're planning to use this terminology moving forward, but we do have a question about what air draft restrictions mean. So if you could take just a moment to clarify that, it might help us for the remainder of the presentation.
Okay, yeah, good question. So air draft would be like a bridge. So like the Golden Gate Bridge has an air draft restriction to not have any conflict or impact with that bridge. So the Bay Area has air draft restrictions because of that bridge, whereas here there's no bridges across the navigation channel. So there are no air draft restrictions at Humboldt. So again, here is just a few things we'd like to point out, and we'll use this graphic a few different times through the detailed discussion. And so again, vessels will be transiting in through the bar or entrance channel that's on the upper left there. On the prior aerial photo that showed where the jetties were in the entrance. They would come in and then offload, and then you can see the marine terminal, which is where the components are stored. That's a combination of a yard and the possibility of a fabrication facility. And so all the components would be stored there, then assembled into the schematic configuration you see on the over on the right. There possibility of wet storage for assembled devices or individual components prior to their preparation for tow out. And so the devices would then be towed back out through the inner channel. As you're going from right to left, they're depending on the type, size, and details of these devices, there may need to be some ballasting for stability before it's towed out through that entrance channel. Others may be able to be towed directly out into open ocean and then ballasted there and then taken out to the final deployment area in the wind farm. So the study methodology, again, just as a reminder, what we did in this phase was a pre-feasibility level assessment. This isn't a detailed evaluation, and as Arnie said, it's not a design or evaluation for a specific project. It's more of looking at infrastructure relative to a possible offshore wind farm development. And our methodology then is a combination of things. First, we visited with a number of folks and stakeholders when we kicked off the study. So we did a site inspection looking at all the different facilities, getting a good idea of on the ground what the conditions are. We did a full data compilation and review, both of local available information, but outreach to other government agencies, and a lot of industry outreach as well, where we're able to get information on prototypes and literature, and other stakeholder engagement included the Vessel Pilots Association, the Harbor District, and again, developers. And so then that framed the basis for a conceptual level analysis, and then the development of potential pre-feasibility level upgrade schematics, and some of those we're going to show today. And then again, development based on that, order of magnitude cost, and what type of time frame for implementation for those upgrades might be needed. With that, I'd like to turn it over to Aaron.
All right, thanks, Shane. So I'm going to first go through just some of the findings relative to marine navigation, and then through some of the findings relative to the marine terminal upgrades, and I'll follow up with the cable landfall. So Shane went over this a little bit at the beginning, but navigation, when we're saying navigation, we mean sort of the marine roadway with different sort of parking lots and transport routes between those. So this first section will talk about the bar and the channel, the inner channel, different wet storage and staging areas, which are sort of like the parking lots to go along with the roadways, and sort of some of the capabilities, constraints, and needs associated with those. So say navigation facilities, I guess there's two factors, like Shane said. There's the imported components, and then once assembled, the tow-outed devices. The imported components are similar, could be similar vessels to the vessels that currently use the harbor. This is an existing forest products vessel. Accesses the harbor through the entrance channel, and up and down the inner channel. And the entrance channel is dredged, and this is an example picture of a dredge here, and subject to winds and waves and currents. But we have pretty good confidence that the existing infrastructure can meet the needs for the component delivery vessels, since it meets the needs for the forest products vessels. A little different are the unique devices for the floating substructures. So these are, as Shane noted, wider and potentially deeper than some of the existing vessels that access the port. The important aspects to assessing whether or not these devices can access the entrance channel or the inner channel are the device geometry, then also the device motion associated with towing those devices, the safety clearance to the seabed, and then variations in the seabed height over time and in space. So as the channel silts in, there's a difference in seabed depth in different parts of the channel. So that's how we're talking about it in vertical. In the horizontal, there's also device movement associated with waves and currents and other maneuvering requirements where the actual corridor needed for the device transport is wider than the device itself, and the width of that corridor that's needed is dependent again on how well it can be controlled, and those different environmental forces affecting it, like waves and currents. But the existing navigation system, of course, was designed specifically for forest products for certain classes of vessels with the associated safety clearances, whereas it wasn't necessarily designed for the towing of some of these wider, bigger vessel units. So our assessment is focused a little bit more on the specific needs of towing the devices rather than the deeper draft vessels. So we went over this a little bit at the beginning here, but I wanted to put up just a nice clean schematic of the different geometries for the harbor, or for the navigation channels. So these are the different federally designated channels, or federal navigation channels, in which deep draft vessels use to access the harbor. There's the bar and entrance channel, which is around, I think, 48 foot deep. The North Bay channel, which is not as deep because it's it's not subject to the same amount of waves and currents as it is for the outer channel and the Fields Landing channel, which is a little narrower and shallower than the other two. So these channels were designed based on the conditions and the types of vessels using those facilities. Or the depth and the width will vary between those. So I'm going to sort of walk through this figure. It looks a little intimidating at first, but I'm going to start here on the right, go out to the left. So as some of these devices are assembled up near the port and towed down the inner channel, one of the things I have listed here is interchannel width limitation. The inner channel is around 400 foot in width, and the devices are potentially that we assessed are between 200 and 300 feet in width, and that's a little bit tight relative to some of the criteria that we looked at for geometric requirements for towing a device of that size. And as we get farther down, we have the different available staging areas. So those are areas that might be available for a device to be stored until the conditions are more favorable enough to tow out to the sea. The device would get towed around the corner here. And again, this channel was designed for deeper draft vessels and not necessarily narrower deeper draft vessels and not necessarily some of these wider specialty units. And we identified this as an area that could be potentially tight or have a limitation on the width of the beam of that device for safe navigation. As we get out into the outer channel, there's seasonal shoaling in the channel that can affect the available depth for tow out of some of the devices. And that channel can shoal, meaning it gets less deep in the winter due to some sedimentation, which could limit some of the times of the year where it is towed out. And there are some limitations here, but I think the big story, or the short story, is it looks feasible to tow devices in and out of here. But there might be some device limitations in terms of size, considering the existing geometry of the channel and the schedule for the typical time of year where there is shoaling in the channel. Shane, anything to add there?
No, yeah, keep going.
All right. So I mentioned there's a timing element to the depths in the channel. This is a real concept example of what a potential controlling depths are in the channel as we go throughout the year. Earlier in the year, we got January and February starting out here. We have an example winter storm hitting and shoaling the channel, or filling in the channel. As we go throughout the year, waiting for the potential maintenance dredging to occur, that channel is shallower than the authorized depth of around 48 feet. So what does that mean? It means that some of these devices may not be able to use the channel for a certain period of the year if this was the example maintenance dredging schedule. If, let's say, a winter storm hit in February and then the dredging occurred in July or August. That's important because that means there may be some times of the year where the winds and waves may be more favorable, but if the channel is filled in, the devices may not be able to be towed out, or some of the component delivery vessels may not be able to come into the harbor to deliver those components that would be used to assemble the devices. Shane, anything to add there?
I think, yeah, the main point there is overall is just that, you know, it appears feasible to be able to tow these devices out. And as Aaron mentioned, deeper draft vessels coming in with the size components that are needed. You know, it's really going to be the size of the device. There's two ways of looking at it. Either the channel may affect the size of the device that can fit within that channel, or, you know, there might need to be some, you know, improvements to the navigation channel locally in certain areas if a larger device was needed. Yeah, go ahead, Aaron.
All right. So a couple other aspects we looked at, I mentioned those parking lot areas as part of the marine roadway, was wet storage. So similar to other major port areas where there's anchorage offshore to allow consistent throughput at the port. Similar may be done for some of the substructures that are delivered to the port or fabricated here, waiting to be assembled before they're towed out. So part of our assessment was, one, is there room to do that? And I think the short answer, it looks like there is some room to put a number of different substructures in there as wet storage or anchorage to the north of the Federal Navigation Channel there, turning basin, to still allow for also a fairway for other vessels to navigate. Another aspect of the study we looked at was, is there some potential area near the entrance to the exit to the bay where some substructures could be stored for short term or ballasted so that they can be towed out to sea in favorable weather and potentially with ballasted depth. I think the short story here is there looks like there are some areas where staging may be possible. It's really dependent on the device geometry and needs itself, whether or not the device needs to be ballasted or not, or it can be ballasted at sea. And what the exact draft of the vessel is really going to affect sort of where these available areas are for staging and ballasting. So that's to be determined and is really dependent on some of the operational constraints and device geometry. So now I'm going to move into the marine terminal. That's where we're looking at the yard, so the upland area where device components are stored and staged, as well as the wharf itself, so the overwater structure. So to do this, sort of looked at a range of potential facilities that are located adjacent or near the Federal Navigation Channel, and developed different criteria to assess whether or not those were capable of supporting a floating offshore wind terminal or not. And what we weren't assessing is structure condition. So I've got here a picture of RMT1 wharf, and it looks like it's in more of a deteriorated state, but that doesn't mean that this type of facility can be used for a floating offshore wind, because we're assuming that, or we understand that the live load requirements for floating offshore wind, because the components are so big and heavy, are much more than the live load requirements for the forest products industry. So what we assessed first was really just the upland area. So is there enough area around the marine terminal to store components? And two, are we able to construct a wharf without having major navigational impacts? And can vessels and devices access that wharf? So conducted a screening analysis both for assembly and operations and maintenance facilities. That's what's here on the left. So in green, these are the facilities that met our primary criteria of enough upland area and not having significant navigation impacts. And then red would mean that the facility does not meet the primary criteria of having enough upland area or having enough not having navigation impacts. And there's more locations that can potentially support O&M, because those upland area requirements and navigation facility requirements are not as high. So there's a number of different O&M facilities that could potentially support operations and maintenance for crew transfer vessels for minor repairs out at the wind farm. So this is, Shannon mentioned this before. There's just a couple terms here that I'm going to use in the next few slides. I want everybody to be sort of aware of. That's the yard, where the storage of the components are going to be, the wharf, so sort of the overwater structure, and the berth. And that's the sort of the area where the vessels are coming to port, and where they're navigating right next to the wharf to come up to moor. What we're not focusing on, what we talked about earlier, was the FNC, or the Federal Navigation Channel, here on the right. So we developed a few just hypothetical terminal layouts for the assembly facility. Here on the left is a hypothetical small project showing the yard potential wharf and a potential berthing area relative to the existing Samoa turning basin. And in that dashed line here is the existing RMT1 wharf area. Secondly, have a hypothetical large project. The reason it's a little bigger in terms of the yard and the berth and the wharf is there's going to need to be more throughput, so more vessels coming through, more devices being assembled and towed out at a higher rate. So because of that, you have to have a larger yard for storage of components and more berths that can be exclusive use to different types of activities. Whereas on the smaller hypothetical project, there's the potential to have a multi-use berth due to the lesser throughput. Each of these have some similar considerations. So the yard, there appears to be sufficient space at the RMT1, RMT2 area for either size project. That total area is going to be dependent on what those navigation constraints are. So if we have fewer navigation constraints at the entrance to the harbor, there might need to be less storage needed because there's more constant throughput of components coming in. Ground improvements are likely just to have enough capacity or live load capacity to store those components. There might need to be some grading associated with that or leveling of the ground. The wharf, for both the small project and the large project hypotheticals, orientation and location and exact size should be coordinated to minimize any impacts on the eelgrass beds. There are, we understand, some eelgrass beds in this area, but that would need to be looked at in a little more detail going forward. Important to note that in either case, dredging is likely required to support assembly or component delivery. And if fabrication is going to occur in the area, it's potential additional exclusive use berths and maybe a potentially larger yard area to support another exclusive use sort of terminal for that purpose. Shane, anything to add there?
Aaron.
Yep.
Oh, this is Sarah. I just wanted to wave a small flag with a 5 minute.
All right. Sounds good.
Thank you. We're
on target. So Shane, anything to add there?
No, yeah, that's good. Keep going.
So, what I guess the question is, well, what needs to happen? What are the concepts for what that structure looks like? First, we have the existing conditions in RMT1 would need to be the pile field there, if that's where the wharf is going to be constructed, pulled out, those creosote piles to be pulled out so that a new structure can go in. The level of removal is more dependent on sort of what level of extraction is required. But looking at the geotechnical conditions at site that we do have, right now it's looking like either a pile concept or a fill type concept. A pile meaning concrete or steel piles driven into the ground. There looks like there's a good layer of soil, potentially below a softer, poorer layer of soil that may be able to support the piles. But if not, we might have to go towards more of a fill concept, and that's going to be pending additional geotechnical investigations. But for the moment, it looks like either is precluded. Both look feasible for construction of a high-capacity wharf to support assembly and component import. So, summary for the port infrastructure assessment. Navigation channel looks like it can likely support offshore wind projects in general, but the device size needs to be coordinated with the throughput requirements for the project. Bigger devices with the same channel geometry will have less throughput per year because there'll be more constraints on towing those devices out. The existing marine terminal, there's space to build a new one, but the existing one, both the yard and the wharf need upgrades. Those upgrades in terms of the navigation channel, you mentioned that installation throughput might be dependent on those channel modifications. But on the inner channel, it's not the conditions, but the widening may be required depending on what the device geometry is. So there needs to be some coordination in terms of some more maneuvering assessment of what those device geometries are that could safely navigate the inner channel. On the marine terminal side, berth dredging likely required. The wharf, a new wharf is required. You mentioned the grading and yard ground improvements. Operationally, seasonal installation looks likely due to the wave climate out in the Pacific, but components may need to be delivered year-round, which could affect the timing adjustments needed for maintenance dredging in the channel. So even if assembly of the devices doesn't occur and installation of the devices doesn't occur in the winter, there may need to be some additional components brought in during that time of year. And then yeah, other uses. So just wanted to note too that the marine terminal exceeds capacity and length needs for other industries, and after use for assembly, it could potentially be used for other industries as well. Rough order of magnitude costs for the small to large facilities, that's in the $50 to $100 million range for small, potentially $150 to $300 million range for large. And then if there's an additional fabrication marine terminal, that could be 50 to 100. It could be less, depending on some of the details. But at this level of assessment, it looked to be around that range, where the O&M marine terminal portions would be significantly less than that. I'll turn it over to Shane to talk through the schedule.
Yeah, and on the schedule, you know, for something of this size, both small and large, there's a multitude of regulatory considerations in addition to in-water work windows. And so, you know, the smaller scale would, of course, the schedule for implementation would be shorter than a larger scale. Some of the bigger factors is just the scale of the area affected, in addition to probably would require a multiple years of in-water work windows in order to potentially get the work done. So, you know, we're estimating, you know, 4 to 6 years versus 5 to 7+ years, depending on the size and details of what the development would be.
Okay, and then just some example areas for further investigation. I'll go through this pretty quickly because I know we're short on time here. But starting on the left side to the right side, on the left side is maneuvering analysis and some of this additional simulations needed for some of the developer side folks to look at what are those devices that we can really fit in the existing navigation channel system. We know that it's possible, but is there some refinement of the size that would be appropriate for the existing infrastructure, or what improvements might be needed to meet those throughput requirements? And then in green, more on the port development side, what some of the additional analyses are that are needed for that. And then on the right side, just a couple of other important next steps in terms of stakeholder outreach, regulatory coordination, and then data needs such as surveying and geotechnical investigations. I think sort of big story, the short story is, I guess, feasible. Device size might need to be coordinated to make sure there's safe navigation for the throughput that's required for the project on the navigation side, and then on the marine terminal side, facility upgrades are feasible but require investment. And Shane, you want to add anything to that before we go to cable landfall?
No, I think you got it covered.
All right. So real quick before we finish up here, part of our assessment was looking at cable landfall for an export cable from the wind farm. So that's where the cables are buried in a trench out to the wind farm location, brought up to the beach in conduits that go from sort of the upper berm out to below the water level. And I'll show a transect here next. There might be 1 cable or 6 cables. Those conduits under the beach are installed potentially using a horizontal directional drill under the beach, which is kind of like a sort of a small tunneling machine that creates a conduit so that the cables can be pulled through from offshore up into the uplands. Due to the length from sort of the bay side here out to the ocean, there need to be first a cable landfall on the spit and then a secondary HDD conduit installed underneath the bay over to the mainland side. It's too long to go from this area all the way under the bay and under the spit out to the ocean. So there's a few different options. These are just hypothetical alignment options, but looking at it briefly, it looks like there's options either in the south spit with the crossing over the bay here, or an option anywhere on the north spit with a crossing across the bay on the north side. There's it's short enough where an HDD is possible from the north spit over to the mainland as well. I just if in this assessment, the Humboldt Bay Generating Station was our substation location, so it would be a longer upland route if that were the case. The trenchless technology, again, likely feasible, but wanted to note that this looks simple here on the top. You just drill a tunnel basically into the ocean from the spit, but it looks simple, but it can be one of the most complex elements of the project, and it's really important to get right so that you don't have a derating of the cable, meaning if it's not done right and assessed right, there's a risk to derate how much energy can go through the cable. This assessment focuses on HDD, which is one of the most common trenchless options for landfall. And I think important to note here is wherever that landing location is picked going forward, good assessment of utility access, truck access, and then assessment of barge and other vessels that are needed to support the punch out of the HDD on the ocean side. And yeah, thank you for your time, and sorry we went a little bit over.
Fantastic. Thank you so much, Aaron and Shane, for your presentation. Very informative. So I'm going to now screen share and move us into, Aaron, would you mind stopping your screen share?
Yeah.
Please. Perfect. Let me try again. Perfect. There we go. Okay, so we are very honored to have 5 members of our local community and the broader renewable energy community as panelists today to share their thoughts and their reflections about the information that Aaron and Shane just shared with us, as well as Arnie earlier. These panelists were selected based on their areas of expertise and because they represent a variety of perspectives related to the potential for offshore wind development in the North Coast. So I first want to welcome our panelists. We have with us today Tyrone Connor, Deputy Chief of Waterways Management and Chief of Aids to Navigation for the 11th Coast Guard District. We have Adam Cantor, Tribal Botanist and GIS Specialist for the Wiyot Tribe National Resources Department, Table Bluff Reservation. Sharon Kramer, Principal and Senior Management Biologist at H.T. Harvey & Associates. Larry Otker, Executive Director of the Humboldt Bay Harbor and Recreation District. And Antoine Pfeiffer, Vice President of Engineering at Principal Power. So thank you to all of our panelists for being here today. We're really excited to hear from all of you. Just as a reminder, I'll present each one of you with a question and ask that you kindly limit your response to about 3 to 4 minutes. And I will find a suitable place to interrupt if we're running tight on time and we need to move forward to the next panelist. So thank you for your understanding. We just want to make sure that we can hear from everyone. Okay, so I'm going to stop screen sharing so that we can see our panelists' lovely faces. And I would love to start off with asking a question for Tyrone. So Tyrone, what role would the Coast Guard play in relevant regulatory or permitting processes related to offshore wind development?
Well, thank you for the question, and thank you for having the Coast Guard part of this panel. We're excited to be pre-discussing this because the earlier we can be engaged, we hope to better the process and make sure there's less confusion. So where the Coast Guard's main role with this will be, under the waterways management, there's a multitude of entities in the Coast Guard that will be part of this, and watching the presentation is really great. But under the Rivers and Harbors Act of 1899 has the Section 10 permitting process, which goes through the Army Corps of Engineers. What the Coast Guard does is it reviews the navigation safety of the applicant when it deals with anything in the harbor or anything offshore. So the applicant, once they're awarded the lease, they would be required to pre-engage with the Coast Guard when they engage with the Army Corps of Engineers to try to reduce the amount of time that it takes to review their navigation safety risk assessment. Because we want to look at to make sure that all waterway users have a safe environment to operate. This project kind of co-aligns with a lot of what we're seeing on the East Coast. So we're taking a lot of the lessons learned that the East Coast is working through right now with navigation review, with the Ports and Waterways Safety Act, and the crew vessels and the dead ship tow of the floating wind installations, and even the harbor improvement. That's the main areas that we will be a part of to make sure that we can keep safe navigation flowing through Humboldt, and working with the port specifically to make sure that all entities are carrying out all operations safely.
Fantastic. Thank you so much. And do you foresee any specific benefits or concerns regarding changes to port infrastructure or operations?
Well, we love being part of this whole waterways management. I mean, that's what our main job is in our office. So this is exciting to actually be able to discuss about a complete new harbor development, because you don't get too many opportunities for this. Most harbors are mostly developed, but this is a large scale project. So there's definitely a lot of areas that we will be focusing on, talking about the navigation channel. A lot of the Coast Guard buoys and fixed ATON is out there. And so that is part of it, to make sure that it aligns with what the Army Corps establishes as a federal channel. So we get involved with that discussion with the port and everything, with the dredging operations and carrying out to make sure that we can get the deep draft vessels in safely, and then also get the structures towed out. The whole towing evolution would take a lot of Coast Guard involvement, because it's what we consider basically a dead ship tow, because the structure has no propulsion capabilities. It's all towed by tugs. So that whole coordination would have to come through the Coast Guard, potentially maybe limited access areas to restrict navigation to allow for a safe movement of that floating infrastructure. It's the same thing that is going on down in Corpus Christi, Texas, with the mobile offshore drilling units and the floating offshore installations. They tow out the same similar size structures out of Corpus Christi that are brand new built in there, and then they're coming out. So, we take lessons learned from other ports, and we will utilize those into this harbor to try to streamline and make it easy for everybody.
Fantastic. Thanks, Tyrone. Adam, would love to move to you next and hear your thoughts on this question. What is the Wiyot tribe's perspective regarding offshore wind development here on the North Coast? Are there priorities, questions, or concerns that the tribe would like to highlight during the early stages of gathering information about potential offshore wind development in the region?
Well, Atwatlo, or greetings in Wiyot, and I want to thank Arnie for his acknowledgement earlier that Humboldt Bay, or the Wiggy, is part of Wiyot ancestral territory and been home to the tribe since a time immemorial. And I also want to say that as a single representative to the tribe, I can't possibly express every perspective and opinion relative to the Wiyot, but I have discussed offshore wind with our tribal chair, our cultural liaison, some elders, and tribal youth. And in general, the Wiyot tribe has long supported renewable energy development that is well cited, and are open-minded and excited about the potential for offshore wind on the North Coast, especially the community-based approach and stakeholder involvement that this group of partners is taking early on during the planning process, kind of like what Tyrone mentioned. Tribe really wants to support solutions towards reducing our greenhouse gas emissions associated ocean acidification, climate change, sea level rise, and in general, we support the port upgrades and associated economic development that could occur with such a project, as well as the marine terminal cleanup of like the creosote piles and other old industrial waste that would be taken care of as a probably a plus to this project. Some concerns that the tribe has were about dredging and dredge spoils disposal, the export cable landfall location, potential impacts to shellfish and eelgrass populations in the bay, kind of impacts to birds, noise impacts to wildlife, impacts to the snowy plover, the migratory black brant, and the bay's main heron rookery, which is kind of right across from Redwood Terminal 1. Impacts and delays and safety to fishermen and navigation, and then impacts to tribal ceremonial and cultural activities at the island of Tulawat, which is the Wiyot center of the universe that also lies kind of right across from Redwood Terminal 1. And just general impacts around the bay, both, and offshore, as well as the overland transmission route. But we hope that early engagement with the tribe and other stakeholders that such a project could avoid and mitigate any negative impacts. And we're excited to take a deeper look at some of the biological survey work that is being conducted and digest more literature on all these subjects. Thank you.
Fantastic. Thank you, Adam. Yeah, and hopefully today we'll be able to address more of those questions and concerns through the discussion with our other panelists. Okay, Sharon, would love to come to you next and hear what are the most important environmental considerations associated with port development in relation to offshore wind development, and how can these concerns be addressed in the near and long term? Would love your thoughts on this.
Yeah, thanks, Sarah. I think I'm going to repeat a lot of what we've heard so far. One of them is something that Shane and Aaron said, which is that the scale of the project is going to define the amount of disturbance associated with the harbor infrastructure, both construction and the operations and maintenance. So larger scale project, larger footprint, larger impact, longer construction. So let's start with dock facilities. One of the major issues with dock construction is going to be the noise. Again, if there's going to be pile driving, these are all, it's early to say what's going to exactly happen, but different types of piles will be needed to support the piers. And so the noise effects on mammals, marine mammals, nesting birds, fish, will depend on the amount and type of pile installation that occurs. Long term, the bigger concern is with respect to eelgrass. It's come up already. Aaron said that eelgrass habitat is very difficult, if not right now, almost impossible to do appropriate mitigation for, and it's compensatory mitigation that's required in the state of California for eelgrass. And so there's effects associated with new piles going in, old piles coming out, and dredging and so on and so forth, shading associated with the pier structure itself. So all that's going to have to be addressed, and that's going to be looking forward. I think that was the second part of the question. That's going to definitely be something that needs to be planned bay-wide, is how to compensate for eelgrass effects. Dredging is another important aspect. The timing, if new areas are being dredged, the frequency of dredging. There are already permits for dredging with the Corps in the bay. They'll have to be relooked at if the timing and frequency changes or new areas are dredged. We have very important listed species, juvenile salmonids, adult salmonids, coho salmon, longfin smelt. So they're really important things. And then the byproduct of dredging, which is the sediment. Will it be available for beneficial reuse, or will we continue to do offshore disposal? And if we continue to do offshore disposal, those are effects we have to also address. Another one is vessel traffic. We're going to have more vessels, and vessels are noisy. They have propeller wake. So there's all these aspects that we need to look at when there's a project that we have in our hand. And lastly, turbine assembly. And there has been a concern raised about how long the turbines will sit in the bay. Will they be tested before they're towed offshore? And so there will be a different suite of birds that have a potential for collision with turbines while they're situated in the bay. And then I think Aaron touched on the cable landing effects. The noise associated with horizontal directional drill will be an important aspect with respect to nesting plovers. Plants and other things can also be disturbed through just activities on the South Spit. I won't repeat anything other than to say this early coordination with the resource agencies, the tribes, and other regulatory agencies is super critical as a next step. And that's really going to be important for making this project successful for sure. Thank you.
Thanks, Sharon. Appreciate it. Coming over to you, Larry. How do the analyses and scenarios presented here today align or not with the vision and plans of the Humboldt Bay Harbor and Recreation District?
Thanks for having me. As our name says, is that we are the Humboldt Bay Recreation and Conservation District. You know, we regulate all the state tideland leases below high tide level. We own several hundred acres on the Samoa Peninsula, essentially a mile of shoreline between the Samoa Bridge and the old pulp mill. All the tideland leases of all the docks, essentially on the Samoa Peninsula and in South Bay, are leased by the Harbor District. We also coordinate with all the property owners that own upland areas to help out with coastal dependent lands. So in essence, our vision is to prepare the port for the 21st century. We're looking to have clean, green, and a blue economy is what we want. We need a 12-month port. Everything that what they've been saying is what we need. Infill development, replacing these wooden docks. Our objective is to be the West Coast hub for renewable energy, to be the assembly, fabrication, substructure, anchoring, manufacturing, to basically start the development in Humboldt Bay and then ramp up to the Central Coast as those areas develop, and then also supply the wind turbines for other areas. And then we can also be the operational and maintenance port so that they can return the platforms here for maintenance of the platforms and towers instead of having to do those repairs out into the ocean. Unlike most of the other what's been described, the Harbor District is in project mode. We've been trying to develop a multi-purpose dock for years and years and years. We recently received a Headwaters grant to begin to clear the obstacles for development for port infrastructure, where we're looking at specifically the sea level rise impacts. We've already done the wetland delineations, biological reports, the eelgrass surveys, cultural resource assessments. We still need to do the detailed geotechnical, like he was saying, are we doing pilings or fill? We still need to do those. There's widespread community support, but there's also a great deal of opposition that needs to be heard and that we have to do mitigation for impacts. In order to succeed, in my opinion, we need to have a strong community benefits package. So this is a win for the industry, the environment, and the local community. We got to have local input. You know, within this community benefits package, there needs to be jobs, apprenticeship program, fishermen's funds to support sea ice, cold storage, life raft inspections, carbon-free electricity, and other kinds of things. The Harbor District is really working, again, to make the Port of Humboldt a clean, green, and modern port so that we can prepare the industry for the 21st century. There's a lot of work to do and a lot of coordination, and we need to design the facilities that match up with what the community wants to see. We can't have a project that the developers are telling us this is how you need to do this. The community has to be the one that says this is what we want. We've been the community of no for a long time. And so how do we become the community of yes? By having a strong community benefits package that basically matches up what the community wants to see and what the industry can provide our area. And so lastly, I just wanted to say that we really have strong partners in the U.S. Army Corps of Engineers, who's doing a $22 million jetty reconstruction project right now. They're also out doing a 1.1 million cubic yard dredging project. The Coast Guard, who's been here since 1856, we have tremendous air and water and improved navigation support from them, also search and rescue and other things. Our federal partners are a huge asset for Humboldt Bay, and we really can't thank them enough. And so we believe that Humboldt Bay is the premier port on the West Coast, and that we really need to listen to the community and to develop a community benefit package that really meets our community's needs.
Thank you, Larry. So moving to our final panelist, Antoine, would love for you to address the question that we have for you. What is your assessment of the suitability of Humboldt Bay for the deployment of floating platform offshore wind systems? What are the most important changes to consider to port infrastructure and operations to enable offshore wind development?
Sure. Hi, Sarah, and good afternoon, everyone. So my name is Antoine. I'm delighted to be here today, and I wanted to thank the Schatz Energy Center for our participation in this panel today. I'll just say a few brief words about Principal Power, just so that everybody understands. We are a floating foundation designer for the deep water offshore wind industry, and we're actually based in California. So this is really our backyard. You know, our headquarters are located in the other Bay Area, which is the San Francisco Bay Area. We are currently deploying about 100 megawatts of small floating wind farms in Europe, and we currently have already 25 megawatts of floating wind basically operating in Portugal that you can see behind me. So I hope that this is what we're going to see very, very soon in offshore Humboldt, not from the beach, obviously, because it's going to be very far offshore, but when you get to the sea, offshore at sea. And we are very excited about the prospects of offshore wind in California, you know, obviously from a clean energy perspective, but also from an economic development perspective. We have been involved, you know, early on in Humboldt for a proposed project by the Redwood Coast Energy Authority, working with different partners. And part of that involvement, we were actually doing a lot of assessments of the actual facilities in the port of Humboldt Bay. So that's why I'm happy to speak about this today. So just back to your question, I think, you know, what caught our eye initially was a really well-suited location with really a suite of natural advantages and key attributes that can make something really successful up there. First of all, you know, the port of Humboldt Bay is really at the vicinity of multi-gigawatt sites for offshore wind. You have average wind speeds of 9 to 11 meters per second. So it's really a world-class wind resource. I really want to state that. You don't really find that in many places around the world. So that makes it quite attractive, obviously, and having such a very nice and sheltered facility like the Port of Humboldt Bay is a key benefit advantage for the local community. It's largely underutilized right now, and there is really large swath of land, of upland areas, of waterfront areas, like we saw in the presentation from Shane and Aaron, that could be really used and redeveloped for offshore wind. So really, we think there is a large potential for this place to become a hub for offshore wind, like Larry was just saying, for the entire west coast of the US. So if the right developments are made, you know, everything can be basically done at this facility, even the assembly of the hull itself. So it's not just about necessarily, you know, installing the wind turbine onto the floaters while the floaters are quayside, but it's also potentially having an assembly facility in this upland area. Aaron touched on that a little bit. It was kind of part of the larger project scenario that they were discussing. And so we can basically, you know, as the scales of the project is growing, we can bring more and more of the fabrication done locally at these facilities, but obviously it requires volume and it requires scale. So the other thing that's really interesting, I think, is the maintenance dredging will have, I think, lower requirements in the channels than in some of the other river areas that you would see in the country. So that's actually great. There is also a lot of space in the port itself for wet storage of the units. It's important for us to have a buffer storage during the installation campaigns of those floating foundations. And so you have a very long north spit, which is very useful for that. And then I think, you know, the key here is really about large investments required, you know, to upgrade the current facilities. So you asked me about the challenges. Really, I think the challenges they are threefold. And so I'm talking really purely technically and economically, obviously today. The main challenge, I think, is the quays and the terminals. They need, you know, suitable bearing capacity. They need a certain physical size. They need a certain amount of water depth at the quay side, and that's not something that we see right now. The navigation channels, I think, would be the number two here, with obviously dredging and maintenance dredging required to keep the bay at suitable depths throughout the year. So the timing of the dredging, I think, has to be is a very important factor. It has to facilitate the installation campaign, which is typically going to happen between the spring and the winter, mostly during the summer. And then what's important, I think, is to continue to coordinate with the existing industries, especially the fishing and logging industry, on the use of the bay itself. Finally, I think Aaron touched on that quite a bit. The entrance of the channel will require some investments, in our opinion. There are really limited weather windows right now for the deployments of the units, and so there are all kinds of solutions that are possible. And we'll need to be able to manage all the swells and the currents that are going to be that the units would experience there. So we need not only, you know, ocean-going offshore tugs to be able to get those units out, but I think we also need some facilities there to basically manage those currents and wave heights and maximize, you know, the sort of transit of the units in different sea conditions. So for example, you know, you could have a very simple open mouth port with breakwaters that could be built there. And this place has been known for being very, very challenging and rough in the past, with many shipwrecks happening in that area. So I would say that, you know, this is truly an amazing opportunity for the local community. And if there is a real multi-use, multi-stakeholder framework that is put in place locally, I think we can be very successful, and I think we can really create the future industry of Humboldt, basically.
Fantastic. Thanks, Anton. Thank you to all of our panelists. I certainly learned a lot, and I'm confident that others did as well. We've had a number of questions coming in through the Q&A and the email. So really fantastic to hear your insights, and look forward to moving into Q&A just momentarily. So just before we do head there, I wanted to invite all the participants to complete the Google Form survey to share your feedback about your experience during today's webinar before you go, whenever that may be. We recognize some folks may have to hop to before 4:30. So we've just dropped the link of the survey into the chat, and we welcome you to click on that and fill it out at your earliest convenience. The survey will also be emailed out as part of a next step, so you'll have until Friday, October 2nd to submit your responses. So welcome your time when you have it, whether that's now or later. And just a final reminder that the feedback is anonymous. No personal information is being collected. And thank you, because we find them extremely helpful. Okay, so with no further ado, let's move into the Q&A. I know that the Schott Center, our speakers, presenters, panelists, everyone is eager to hear from all of our participants about your insights and your questions and concerns related to the information that we've just heard. We've had a lot of questions coming in, so I'm going to get started with the first one, and would welcome Jennifer to respond to this question. It's actually two questions. Are state lands commission permits required for bringing the electricity ashore or for other parts of the offshore wind project? And I'll pause for the first question. And welcome you, Jennifer, to unmute yourself if you'd like to turn on your video as well. Okay. I think we will come back to Jennifer momentarily and try again. Wanted to come around to Arnie. I noticed that most of the studies are centered around Humboldt Bay. Is that due to the way funding requests were made? How do we pursue a study for offshore wind in Del Norte County?
Thanks for that question. There's, I guess, 2 or 3 reasons why we focused around Humboldt Bay. One is that the Bureau of Ocean Energy Management had designated a call area offshore from Humboldt Bay, and so it was natural to focus in that area because there was that designated area. A second reason is that there's a, in terms of the electrical infrastructure, Humboldt County is connected to PG&E and to the rest of the California grid, and so in terms of electrical infrastructure, although a lot of upgrades are needed, we are currently connected in that way, while Crescent City and most of Del Norte County are connected through Pacific Power, and so their connection is primarily into Oregon. And so from an electrical infrastructure perspective, development along the Del Norte coast would be somewhat more complicated. And so while we definitely think that study should take place, that there should be examination of the offshore wind resource and the potential to consider offshore wind along Del Norte, it made sense to start with Humboldt Bay for those reasons, both the call area being there and the way that the electrical infrastructure is currently set up.
Thanks, Arnie. Okay, we have a question from David and a follow-up from Andrea. So I will pause and take the first question and then share the follow-up. So this is directed to Larry or Tyrone. Thank you for being here. We agree. With increased activity during fabrication phases of new infrastructure and offshore wind turbines on the coast, can it be assumed that the need for dredging and disposal of sediment will become even more of an issue in Humboldt County than it already is? The last I heard was that we sold our dredge. Would the offshore wind turbine construction companies or the Army Corps of Engineers be responsible for keeping the bay clean? And welcome Larry or Tyrone to get started, and you guys can build off one another if that's helpful.
So I guess I'll take that as that. I think there's two different things. The dredge that the Harbor District had, that was never intended to dredge the entrance channel or the other inner channels. That's really for the marina. It's a much smaller dredge than the really big dredges that are out in the ocean. And just for context, right now, I had mentioned that the Army Corps of Engineers is dredging 1.1 million cubic yards of material. That's basically, if you took a football field, that's 90 football fields, 6 foot deep. That's how much material, just this 1 year. And so when we look at the 2100 sea level rise and the beneficial reuses around the bay, we need that material for sea level rise, as opposed to taking it 3 miles offshore to the Humboldt Open Ocean disposal site. That's something that we've been working on for a long time. And then also the Army Corps of Engineers with the resource agencies has been working to basically do nearshore disposal, which is to drive the dredge offshore, which then does beach and dune replenishment. That's what the Coastal Commission and a number of the other agencies want the Army Corps of Engineers to do with that material. And so we're actively working to do beneficial reuse of the dredge material.
Thanks, Larry. Tyrone, anything to add to that?
No, Larry's hitting it right on the head. I mean, most of dredging falls under Army Corps of Engineers responsibility for a federal agency. The Coast Guard works with them in concert to, move the aids and get them out of the way and facilitate the dredging options, and then also working with them during emergency situations. So the whole dredging falls under with the port and with the Army Corps of Engineers, but we're here to assist when needed.
Great, thank you both. So the follow-up question to this is that Humboldt always faces a challenge getting federal attention and funding to dredge our channels. It seems this port facility for wind would raise our priority in the eyes of the Army Corps, which would benefit our region as a whole. Is that a possible outcome?
I'll take that. And so I think the short answer is yes. is we got a lot of attention when the pulp mills were in operation, and then also a number of the lumber mills and the log exports were going on. But we've lost a great deal of our shipping out of Humboldt Bay. The wind energy will greatly assist us to regain the ship traffic, which then will encourage the Army Corps of Engineers to come more frequently. And then just one last thing on that is that in the past, in the permits for dredging the entrance, they actually allowed the dredging to occur as early as April in the bay. And so this sort of shortens that window of where the entrance channel might experience some of the winter storms that typically happen in February and March. The permits allow dredging to occur as early as April within the bay. And so more traffic, more attention, but the Army Corps has been really great the last couple of years of helping us. It's just there's new challenges dealing with climate change that we all have to deal with, some severe storms and other things that we really need to address within our port facilities.
Thanks, Larry. Okay, a question for Aaron. What are the estimated costs of keeping the channels clear? Who will pay those costs?
Hey, everybody. Larry, you might have to help me with this one a little bit. I don't think in this, as part of this study, we weren't assessing, I guess, the maintenance costs associated with keeping the channel open at a different time of the year. And same for the funding source. I think, Larry, that might be better addressed to you.
Okay, so typically what would happen with the Army Corps of Engineers, the Army Corps of Engineers, they have a specific navigation channel, as Aaron was mentioning, a specific width and a depth. And in the entrance, it's 48 feet deep, and the width might be, say, 600 feet to 1,000 feet wide. If the industry needs the channel to go deeper or wider, then they would have to pay those additional costs. And then we would have to lobby or work with the Army Corps of Engineers to get them to make sure that they're maintaining the navigation channel to the depths and widths that they're authorized to do. And then lastly, there's another parameter, which is dredging that may occur outside of the navigation channel, which might be, say, the area between the navigation channel and the dock. And then also if there is specific anchorage areas, those areas would have to be paid for by the industry or the property owners.
Thanks, Larry. It seems there's more questions related to exactly what you're speaking about. So here's a related question from Robert. I wasn't clear from the presentation whether the channel is wide enough for a 300-foot wide platform or how much widening would be needed. Could you please clarify?
Typically, there's kind of, go ahead, Aaron, why don't you go ahead?
Sure, okay. So I guess part of this assessment was looking at feasibility of towing like a single device out for, without respect to throughput, and part of it is with respect to throughput. So I guess I don't have a yes or no answer. For the entrance channel, the bigger the device is, the more restrictive the conditions are in which you can tow it out. And so there'll be fewer devices that can be towed out per year, the bigger the device is, given the same conditions. If the channel is wider or deeper, or more importantly wider, then there's more potential for towing the device out through the entrance channel. On the inner channel, I guess it's sort of in that gray area where we're in that spot where we can't say it's feasible or not feasible for a 300-foot wide device to be towed out through a 400-foot wide channel without doing some maneuverability and bridge simulations for seeing exactly how safe that is and whether or not that meets safety requirements in the industry or not. Because our first step here is an empirical assessment to see where are some of those potential constraints. And I guess one of the outcomes from this study was that might be a constraint going forward, which then the industry needs to potentially size their devices relative to that width, or do some additional maneuverability or bridge simulations to see what size is safe to tow out. And then Larry, do you want to take it from there?
For the most part, you know, the simulation would tell us this, but if you think about it, when you're going out the channel, you know, you're going around the corner. And so generally it's pretty calm within the bay, and then it gets much rougher once you go out into the entrance. And usually when you're going around the corner, what happens is that you're most susceptible to the tidal influences. And sometimes the tides will have a tendency to push you in certain directions. And so you need a little bit more width in those areas to give you safety factors, depending upon what the wind and the currents are doing. And so those are what we need some simulation. Basically, there's a model of the bay where you can run a simulation ship in and out of the bay to tell you under certain conditions what the safety factors might be.
Okay, thank you both for that. A question for Shane. What are the draft requirements for the ocean-going ships? Was it the draft of a fully assembled device in the harbor and outside? What is the draft of a fully assembled device in the harbor and outside the harbor in open water?
Well, I think the first part of the question would be, sounds like related to the commercial deep draft vessels. And even though these are big, heavy components, the cargo isn't very dense in the vessel itself. So that works to the advantage for planning and what the requirements are to support those, is that, you know, it appears based on what those size and class vessels would need to be to bring in components that can fit within the existing channel because of the, you know, existing sizes, and they're not that much different, as Aaron mentioned in the presentation, from the existing forest products industry vessels that have used the channel in the past. So as for the device itself, you know, that really is going to depend upon the industry and what they are developing based on their technologies on what kind of beam or width and the draft requirements, not only in its deployed condition out at the wind farm, but also what's needed for safe towing. And I think we had talked about, you know, ballasting is a method for, you know, bringing it down to deeper in the water. Is that required inside the channel and can be done, it has to be done there before it's towed out for stability, as Larry mentioned, that there's various, you know, tides and wind conditions in that entrance channel. Does that specific device type have to be ballasted down before it's towed through, or can it be done out in the open ocean? And so there's a lot of variability on what the exact sizes are, both from a developer design perspective and then from an operations perspective as well, relating to what those dimensions would be. But based on what we assessed, based on some industry outreach, and we got kind of ranges of what those dimensions might need to be, you know, it appears feasible to be able to tow it through. But as many of the panels have been saying, is that there needs to be some maneuverability assessments and things like that to better fine tune, you know, does there need to be, you know, some improvements to the channel made, or maybe the device can be designed around what some of those limitations or current dimensions are. Aaron, you want to add anything to that?
No, just that, you know, for this study, and we'll have the details online later this year. For this study, we assessed a couple different potential sizes, sort of a small and large size, to try and see where some of those sensitivities might be. In terms of draft, I think we were close in the range of between 26 to 38 feet or so in terms of device draft that's unballasted, and then ballasted would be a bit deeper to assess some of the depth requirements for tow out.
Okay, thank you both. A question for Adam. Are there specific dredging or sediment concerns related to Tuluwat that developers and planners should be anticipating?
No, I don't think there were any specific dredging concerns related to Tuluwat. it was one question that the tribal chair had was, you know, is there a plan to use the offshore disposal site, or are we going to be looking at beneficial or near shore disposal? And if that's the case, you know, that there could be potential impacts based on the site. I guess we don't know the answer to that yet, maybe.
Got it. Thank you, Adam. Sharon, would love your insight on this question. Could you explain the concerns and constraints regarding eelgrass beds? Past dredging plans have been limited by a lack of places that eelgrass mitigation can occur. Aaron Porter's presentation refers to minimizing impacts to eelgrass. So how will impacts be minimized or mitigated when that has not been possible previously?
Yeah, that's a tough one. And I think that there will need to be some efforts to figure out banking possibilities, making new eelgrass habitat, and that's not easy in Humboldt Bay. So that's a big challenge. I think it's something that we need to do anyway, regardless of this project, because there are plenty of other projects that are looking for other mitigation opportunities as well. So if that helps, yeah.
Fantastic, thank you. A question for Tyrone, excuse me. How would adjustments be made for other traffic in the harbor entrance and channel?
Well, for adjustments of traffic, the only time I really see a major concern for traffic is obviously when deep draft is coming in with the supplies, and then when a dead ship tow of the floating structure is moved out. In other locations, like I said before, limited access areas like a safety zone was utilized to restrict traffic to support the safe maneuverability of the floating structure. And so part of what was discussed in other questions too about risk mitigation tactics and techniques for the tow out of the floating structure, that's exactly the portion that, not the main portion, but a major portion of the navigation safety risk assessment. We would require that the applicant complete simulations with extreme weather events and whatnot, so we, the Coast Guard, can review the impact that that facility will have on the navigation. So if a new facility is being built along the channel and they want to build these structures right off of the channel, or even and even store them locally and whatnot, that's all part of that navigation safety risk assessment that the Coast Guard's been responsible for reviewing, and that's when we engage, you know, the local tribes, the ports, and everybody else to get their impact and their concerns about this development.
Thanks, Tyrone. And just to say to our presenters and our panelists, we'd love, if you're excited to do so, to have your videos on so that we can try to pretend like we're together in a room and see your faces as questions come from you. Thanks, just saw Aaron pop on. Makes it all the more, yeah, just comfortable, I think, so thank you. Okay, a question for Aaron from Joseph.
I'm sorry, can I possibly add something on the eelgrass?
Oh, go for it, Larry, sorry.
Is that basically Humboldt Bay has, according to the eelgrass management plan, Humboldt Bay has 30% of all the eelgrass in the state of California. We have an abundance of eelgrass. Really, the problem with finding mitigation site is we have so much eelgrass, every place that it can grow is growing. And that's the issue, is it's extremely healthy in Humboldt Bay. And so the idea being is that we have a 6-acre dock that we currently have that pretty much has no eelgrass underneath it. And so that's pretty much the size of the new dock that we have. And so if we remove the existing dock and then we build a new dock, then we're creating eelgrass habitat in some of the areas where there is currently none by removing and rebuilding the dock. And so that's kind of is the strategy that we're entailing.
Thanks, Larry. Appreciate that additional context. Okay, a question for Aaron. A key stakeholder will be the supplier of shore cranes used to assemble the components from the wharf to the floating base. Given the massive height of these structures, has Mott McDonald contacted crane specialists to determine the dock load of these crane and counterweight systems? Who is providing the dock load information to be considered?
Yeah, no, thank you for the question. So part of this assessment did include industry outreach, both to developers, literature review of other similar scale projects for the same size of components that we're looking at here, as well as we're engaged with a number of other crane suppliers for projects around the U.S. and have a I guess a good validation of what those loads are that we've assumed here, that validate a bit of some of the literature review and developer engagement we've had from a range of different developers as part of this project. Shane, I don't know if you had something that you wanted to add to that as well.
Yeah, I would just add, we also did some outreach with some national industrial heavy civil type contractors that have experience, specifically like down in the Gulf. Tyrone had mentioned, you know, kind of lessons learned from a navigation perspective with the offshore oil industry and some of the specialty tow outs. We did a similar review with a few contractors that have experience in heavy lift operations down in the Gulf, and coordinated with them on, you know, what do these devices look like? What are the sizes? What are the heights? And got some feedback from them on what they see as in the marketplace. So not only talking to the crane manufacturers, but talking to the contractors that have experience operating these, and they have a landscape of all the different crane manufacturers, kind of what's cutting edge, what they've used before and what they see coming down the line and what would be feasible. And then the corresponding, you know, loading and how they would mitigate some of that loading from an operational perspective. And then we use that to translate into assessing a couple of those two different types of docks that Aaron showed in the presentation.
And I guess just to add to that too, you know, the scale of this study wasn't to say, is it, you know, a 3,500 PSF dock or a 6,500 PSF dock, but all of those are going to require a new wharf, and exactly sort of how many piles we have, exactly what those structural requirements are. We don't know exactly what those are going to be yet. And I think the next step would include additional engagement with the, you know, with the crane supplier industry on exactly what those requirements are going to be for these specific components. But at this scale, we're trying to gather sort of a range of what those live load capacities are going to be, and sort of look at the different structure types that are going to be required to support that.
Got it. Thank you both. I have a question for Antoine from David. Could on-site installation of components be done, or would the conditions required, presumably calm, be too sporadic to make that method feasible?
So, I mean, I was talking about the sort of modular fabrication that we can have on our floating foundation. So I don't know if the question is about this, but basically, yeah, you could develop the upland area in the port, and you can actually assemble the floating foundations themselves there, and then you could load them out, you know, just right there at the dock level. And then you could come with an onshore crane and actually assemble the wind turbine while the platform is berthed at quayside. So definitely that's something that, you know, can be done. But what I was saying is that it depends really on the volume of project that we're going to see on the west coast of the U.S., because you need to be able to justify the types of investments needed to actually do this type of construction operation there. Right, so it's quite expensive to get started and to set up all those facilities to be able to do all that in terms of construction. So I think, you know, the first step really would be about installing the wind turbine for the smaller project scales, just because you want to be able to install the wind turbine very close to the site, so you can tow the systems from there to the site. The next step then would be, okay, let's try to bring in more of the construction elements into the local harbor if we can. But again, it depends on scale, and it's going to depend on the volumes that we're going to see, because it requires a lot of investments.
And
Thanks, Antoine.
We have a bit more detail on that in the infrastructure report as well, once that comes out later this year.
Fantastic. Thank you. And we will send that, you know, a follow-up when the reports are ready. Thanks for mentioning that. A question for Shane or Aaron. What would the sound and lighting impacts likely be from a turbine construction zone on the peninsula?
Shane, I'll let you take that one first.
Well, that's, you know, there would need to be proper lighting for operations and you know, assembly operations at the facility. And that's something that would need to be looked at in a little closer detail on what those would be. You know, there'd be need to mitigate, you know, light not only over into the adjacent landside areas, but also, you know, there's light considerations for over water as well. And that's a common design element in these kind of waterfront marine port developments. But that would need to be looked at in more detail based on the actual footprint that's needed and the exact location relative to the berth. And, you know, the elevation too of where that's being developed. I think Aaron had mentioned there's a couple different elevations along between RMT 1 and RMT 2. So, you know, the elevation make a difference as well.
Thank you. A question to Sharon from David. Has Hog Island Oyster Farm had any input on this project?
I'm not aware of that. Sorry, I can't really answer that question.
Any other folks willing to take this? Or perhaps they put it in the parking lot?
To my knowledge, there hasn't been specific outreach to the oyster farm unless there's something, Larry, that that you or the Harbor District has done in relationship to that.
At this point, what we've been focusing in is the direct impact, and currently there are no oyster operations in the navigation channel, nor would they be allowed to be within the navigation channel because the navigation channel is identified for navigation purposes. And so the Hog Island is located off of the Fairhaven dock, and they're typically located behind the dock interface. And so we haven't looked at sort of the secondary impacts or secondary potential impacts at this point.
Got it. Thank you both. A question for Antoine, Aaron, or Shane. It was well explained that the upgrade of existing infrastructure is required to accommodate the floating wind turbine. The characteristics of the floater, such as overall width, the towing draft, are important information for the planning purposes. My question is, how much flexibility can the floater design have for a given capacity of the wind turbine? The most efficient design may require more upgrades of the existing infrastructure and higher cost. Who is the party to look after the overall cost for the deployment of the floating wind turbine? So the first question is related to flexibility for the given capacity of the wind turbine. And the second question is the responsible party for cost and deployment.
Sure, I can take the first question on the flexibility of the floater design. We do have some flexibility on the floater design, and we do try to adapt to the local infrastructure as much as possible. And there are obviously different methods that we could use to be able to minimize the amount of upgrades needed. But I think that at some point, when you really want to achieve volume and scale on large commercial projects, upgrading the facility will actually save you more money than to try to design the floater in a different way with maybe more challenging, installation methods. At the end of the day, it will minimize the risk on the project. It will maximize the efficiency of the project. So there is really, I think, a bit of a trade-off in terms of how you want the floater to look different and how much you want to actually invest in your local infrastructure. So it's a very difficult trade-off to find. But I think, again, with scale, it makes more sense to look into upgrading the facilities. Yeah.
I'll just chime in here. I think it's a very insightful question, and the most efficient design may require more upgrades of the existing infrastructure and higher cost. Really, it's going to need to be a balancing act because it's more than just the cost as well. I mean, you heard from many of the panelists that there's environmental considerations, environmental impacts that need to be balanced with costs and also time. Time for build out and deployment and things like that. So there's a variety of factors that I think ultimately will find that optimal element of balancing between what the size requirements are and flexibility from the device operations itself to be able to tow it out with the infrastructure requirements, and then balancing the environmental elements and the costs. But I think as for who would pay for it, I might, unless Aaron, you have something else to add, I probably should bounce it over to Larry to.
No, I just add on the technical side, it might be a bit of an iteration to see, where are those infrastructure upgrades that make the most sense to support different types of geometry and of the floating device. Whether it's in one part of the channel, another part of the channel, or a different size wharf or in the yard. I don't think those questions have been answered yet. It might be a bit of an iterative process to see what's the best path forward. I'll hand it over to you, Larry, if you wanted to add something.
Well, just and I forget the exact year, I think it was in I think it was 2008, the Harbor District basically petitioned the Army Corps of Engineers to do channel modifications. And so where we took the entrance channel used to be 38 feet, and then we requested, and they ultimately increased the depth to 48 feet, and they also did some widening. And so on who's going to pay for some of these improvements, there's a distinction between, is it within the existing channel and is it within the existing parameters that either the Coast Guard has with the navigation or the Army Corps of Engineers, or are we asking for something new? And then most likely we would either have to petition Congress to specifically authorize them to do that, or there would have to be paid for by the port or the developers.
Got it. Thank you, Larry. Tyrone, how do you communicate traffic limitations to recreational and commercial fishing bay and channel users, such as kayakers?
So yeah, that's a good question, because communication is always comes up being an issue when we have any event going on. So the Coast Guard's role with that is, if this facility got built and they're building these structures and they're having to tow them outside, one of the Coast Guard's requirements would be for pre-planning event, and we'd work with, again, all the interest parties, local fishermen, local harbors, the port, and obviously the Coast Guard and the tug companies and everybody else. And we would require that planning to happen at least 30 days in advance, maybe even longer, because that evolution, even though it's about a one-day event, my experience of working these in the Gulf, it usually takes, only a portion of the day, but it does impact navigation to everybody during that event. So, the Coast Guard sends out broadcast notice to mariners, and that's on channel 16. We also publish in a local notice to mariners. That's published every week by my office, and that gets it out. We also reach out directly to the port and the Harbor Safety Committee, and then we utilize our partnership with the harbors and the boat launches and everybody out there to make sure that they're aware of these events. Obviously, with a tow out of something this large, the public, Humboldt's a smaller niche community, so word of mouth would definitely be also utilized to get the information out to the public.
Thanks,
If I could add just one thing to that, I apologize, is there would be an expanded role of the existing Harbor Safety Committee. And the port has a Harbor Safety Committee, and it's comprised of the Coast Guard, the Army Corps of Engineers, the Sheriff, the Harbor District, the bar pilots. There's representatives from the Commercial Fishermen's Association, as well as the recreational, and there's a representative for recreational boating, basically at the Adorney Center, the small craft. And so the Harbor Safety Committee really would be analyzing some of those impacts and would be providing some specific recommendations on noticing aids to navigation, other parameters that would have to be done in order to maintain the safety for the entire boating and recreational communities.
Thanks, Larry. So just as we begin to wrap up our Q&A session, here's a question that all panelists can feel free to weigh in on. There seems to be an assumption that assembly needs to occur locally. While this is preferable for many reasons, the cost for upgrading, including deepening the port, is likely to cost hundreds of millions. Will it be worth it cost benefits wise?
Well, I'll just jump in here and then others can add to it. I think one important element you have to keep in mind too is not only the construction and deployment, but then the operation and maintenance. So if there was assembly elsewhere, there would still need to be some sort of operation and maintenance facility provided on an ongoing basis. Now, with that said, from a navigation perspective, it would probably be likely very similar for both the tow out for deployment and for the operation and maintenance. But the terminal side, quayside, would be smaller for an O&M than it would be for the development on the construction side. So there is a little bit of a difference between O&M and the main construction on the marine terminal, but the navigation channel would be very similar between the two. The further distance you tow something like that in the open ocean, there are additional costs for longer towing and additional risks as well the further away you are. So those are all factors that would need to be considered in some of the final, assessments.
And Antoine, I don't know if you want to also respond to that in terms of thinking about if they were to be deployed from another port. Perhaps you spent some time thinking about, is there another port from which that could happen that's close enough?
Yeah, I mean, like Shane was saying, the facility requirements for the operation and maintenance are going to be obviously less stringent than for the actual construction and load out and tow out of the units out of the port. But I think there is still a little bit of a caveat here, because if we want to do the maintenance of the wind turbines themselves, during the lifetime of a project, it happens at least once. Typically, you have to actually change a blade or a gearbox or something like this. That's actually major, and it's very difficult to actually perform this operation offshore. So in that case, you actually have to bring the units back to the facility where the turbine was actually assembled. And so if you have to do this, typically you want to do this as close as possible to the site. And so that means that it's very important, I think, to have the facilities to be able to do the turbine assembly or the other way around, basically, where you want to change a blade, for example, at the same facility. So for this reason, I think it points toward the direction of having at least some kind of quayside in Humboldt, very close to the project, so we can actually do both the turbine assembly and then all the maintenance of the turbines and the bigger components that you cannot really do offshore. But so I hopefully that brings some light on this one. I think responding to the question, I think we need to take baby steps. I don't think we'll be able to go to a full-blown facility for 2 gigawatts of offshore wind. I think we need to do development as we go, based on the scales of the projects that are going to be proposed, based on the size of the leases that BOEM is going to propose, I think. And then based on that, we can work with the local community, the harbor district, and everybody else to understand what really needs to be done, so that those projects can be deployed in the first place. So what does it mean in terms of upgrades? Do we need to go with a bigger dock right away? Do we need to have a lot of space that needs to be developed in the upland area or not? I think we need to look at it basically in steps, a little bit like what you did in your study, looking at different scenarios, right? Different scenarios will require different types of upgrades. And so I would just say, yeah, let's look at it step by step as we build the capacity basically locally and for the west coast of the US.
Thanks, Antoine. Any other remarks from folks related to this question? It's a good one to kind of close on.
Well, I would just say that I think the co-benefits are widespread within the community, I guess, is the big picture is, everything from there are impacts, there's no question, but there are also a number of great potential benefits to the community, from living wage jobs to getting our maritime industry back to the operational level that attracts the investment. Having a multi-use port means not just for the wind energy, but to support other types of industries into the future. Really setting the community up for the 21st century. And then also a number of different ripple effects throughout the economies, from, buying equipment and other things within the community. There was a co-benefits report that was included as part of the package of studies that were put out. And so I encourage people to take a look at that as well.
Thank you, Larry. Okay, well, with that, I will thank all of our panelists and presenters for addressing the questions that came in, and thanks to our participants for asking really thoughtful questions. I thought that went really well, and look forward to learning more as the webinars continue. So now I'm going to screen share my slides. Okay, and just take the next 5 minutes or so to wrap up today's discussion. So once more, there is a link to the survey. We will also drop it in the chat. We would love your feedback by Friday, October 2nd. Not much more to say about that. Today's webinar, as you may be aware, was the third in a series of 5. So the first 2 we've already completed on energy production and delivery, and ecological and geological environmental considerations. Today, you were here with us as we talked about port and coastal infrastructure, and we do hope that you'll join us next week, where we are going to engage in a discussion around community perspectives on regional impacts and opportunities. And if you've been following along, we're excited to announce that we do have a date for our final and 5th webinar, which is October 19th, where we'll talk about reflections from the webinar series, as well as next steps. And so please do note that there is a Monday that's off. We've been meeting every Monday, but on Monday, October 12th, you can take a mini vacation from offshore wind webinars. We will not be here. So in terms of next steps, today's presentation and the webinar recording will be posted on the SHOTS website. Just a reminder that that information is already available for the previous webinars, so welcome you to go back and review that information if you're looking for a recap. Most reports are now available at the SHOTS Center website. 20 of the 23 are completed and posted, and the final 3 will be posted in late fall or winter. So please, as a reminder, check back to the SHOTS Center website to receive updates and see when those final publications have been made available. As I've mentioned before, there will be a meeting summary that is developed that focuses on the key themes and takeaways of each webinar, as well as the variety and diversity of perspectives, questions, and comments that were made from our participants. Poll and survey results will be included at a very high level, but those are anonymous. And the summary will be shared with the Ocean Protection Council as part of this package of materials alongside the report and be made available to the public. And so the timeline for that is, we're hoping, on or around Thanksgiving holiday to be able to share that summary with you. On the same timeline, the SHOTS Center will be working on developing a frequently asked questions document, an FAQ, and that will be posted on the SHOTS Center website. And again, it will consider all of the questions that were received via the chat, email, and so forth. So even if your question was not read aloud today or in previous webinars, it will be considered during the development of that FAQ. So the next webinar, as I've mentioned, is on Monday, October 5th, same time, same place, 2 p.m. to 4:30 p.m. We will be hearing from Dr. Lori Richmond about community perspectives on regional impacts and opportunities, and we're hoping to engage again in a thoughtful conversation with all of our participants. So we do encourage you to register at the link that's shown on the screen, and we'll also drop that into the chat at shotscenter.org/wind, and please register as you've been doing for these webinars. Also a reminder that if you're looking to receive updates about the webinar series or about the offshore wind studies reports themselves, please email windstudies@shotscenter.org to be added to that listserv. We just thought that this might be of interest to the broader renewable energy community that's joined us today. So this is a notice that the California Energy Commission has posted a notice of availability, and they are looking for comments by 9:30, which is 2 days from now. If you have any questions or comments, you can feel free to reach out to Chris or Eli directly. Their emails are shown on the webpage, and this is in response or in regards to California's Central Coast offshore wind energy conversation. So just to be clear, we are very much focused on the North Coast as part of the Shop Center webinar series, and we thought that this conversation may be of interest to some of you, but it is focused on the California's Central Coast. So just want to make that distinction clear. And into the chat, we will also drop this link to the CEC's request for comments on the notice of availability. Okay, so with that, 4:30 on the dot, I am thanking all of you on behalf of SHOT Center for being here today and engaging in this really thoughtful conversation. I hope you've learned a lot and you felt like your perspective was shared and considered during the conversation. We certainly look forward to reviewing and considering any feedback that you share with us and continuing the discussion next week. So from all of us, thank you, good night, and please stay safe.